Then let's get started now. This training consists of 5 parts. Part 1 describes the machine tending application overview, and Part 2 describes the POCUS, which stands for interface between machine and robot. Part 3 describes the DRS scripts for feeding settings. Part 4 describes the program in detail. In Part 5, we will summarize machine tending application. Let's take a look at the training objectives on the screen. Those are the goal of this class, divided into 3 features: usability, productivity, and flexibility. This is a system configuration. The hardware device used in this training can be largely divided into the Robot H2515, gripper, and machine tool. Other components consist of the solenoid valve and the compressor to control gripper and safety sensor. The safety sensor should be set into 2 areas, 1.3 meter and 1 meter, as protective stop auto resume and reduced speed mode based on the center line. When using H series instead of M or A series, the robot base should be installed parallel to the floor with a level of less than 5 degrees. Focus communication interface should be configured after hardware installation and wiring gripper. After connecting the LAN port and machine, check the machine to test whether to read and write PMC data or not. Use a DRL command getPatternPoint to set the pattern point to obtain the coordinates of the fillet. When setting up for equipment, the flow must be confirmed first. After configuring the interface logic based on the determined flow, simulate all processes. Please take a look at the table for working environment. The pallet is a sliding and layer type. 600 mm square shaped pallet. The pallet was designed to tilt about 5 degrees, but it was uncomfortable to handle the workpiece. So we recommended installing the pallet inclined at least 15 degrees from the ground. The gripper used a dual gripper and was configured to allow the gripper to rotate orthogonally through the cylinder. The gripper is available to attach the proximity switch for open-close detection. The robot was H2515 and the base was fixed on the floor to prevent any vibration under the robot's maximum reach. The laser sensor can scan up to 3 meters in the center detection area. At 275 degrees, as I mentioned previously, the area was divided into 2 and connected to the input of the robot controller. This page shows how to set work set item. Specify the robot states when the safety sensor operates, such as a protective stop and auto resume and reduced speed mode. The weight of the workpiece and gripper can be set through automatic measurement. The TCP of end effector is set according to the gripper to be used. The gripper's true center position equal TCP means the coordinates from the origin of the flange to the position of the center of the the tool. If the TCP is not set, the robot moves to the task coordinates based on the origin of the flange. If the distance of TCP is more than 300 mm, it is not allowed to use the pulse and compliance control. In this case, an alarm message pops up when saving the end effector. If we use the dual gripper, since we use 2 TCP, we must enter the rotation value. Doosan Robot use Euler's coordinates RG, RY, RG, set the final direction by rotating the angles inputted to the A, B, C value in order. After rotating A by -90 degrees, then enter the angle of Rx in B, and rotating C by 90 degrees, Rx can be applied. The rotation of gripper in the RY direction can be applied relatively without inputting a value for C. The tool weights should be added according to the number of cases when the gripper handles the workpiece. For stable use of force control, check the external force on the robot. Also, accurate tool weight settings are also necessary for collision detection or TCP force monitoring. When using dual grippers, data might be different depending on which gripper is picking up the workpiece, whether the workpiece is before or after processing. Please look at the number of cases shown on this slide. As described previously, for the exact tool weight auto measure function, it is also necessary to check in advance robot position. Even if there is only one point in the same task coordinates, the external force acting on the robot may differ depending on the solution space. Please note that the tool weight should be measured in a position without interference with the machine store and equipment inside the machine. This is a gripping system configured to handle a cylindrical workpiece generally. It is a combination of the orthogonal rotation unit of the JRT and 2 AF46 grippers. A proximity switch for detecting doors opening and closing can be attached to monitor the status of the gripper. The rotary unit has the advantage of reducing the cycle time by rotating the gripper without using robot joint rotation. It can also be used when there is not enough space to rotate the joint of the robot. This slide is for robot and pallet and machine positioning. When handling pallet shelves, review the singularity of robot and need to maintain a straight line when pushing and pulling pallet shelves. The center of base must be installed to prevent shape 5 and link 2 from interfering with the machine tool. Considering the length of the workpiece, it is necessary to check whether approach and retraction are possible when loading or loading the chuck. If the space where the workpiece is placed deep inside the machine, review whether the robot has sufficient reach to handle all the works on the pallet. When handling heavy workpiece using the H series, in consideration of the payload and the rigidity of the robot, the teaching of each position must be carried out under the payload condition to ensure repeatability. Besides, the vibration may occur, which does not guarantee the occurrence of the phase, so sufficient tolerance must be secured. The free space of the feeder should also be considered. The feeder can naturally change position due to vibration or collision of the robot. The feeder also requires a tilt of at least 15 degrees to allow the workpiece to slide naturally. The design of the feeder should be considered by taking the shape of the workpiece. If the feeder is transported in the shape of a cart, it must be configurable to dock in the correct location. If accurate docking is difficult, you can test using the user coordinate system through vision calibration. A waterproof jacket is also required to protect the robot against lubricant. The jacket sold by Doosan is only water protected, not oil protected. TCP 300 mm must not be exceeded to use force compliance control. Because force control is point-based and the longer TCP can be detrimental. When setting the workpiece on the jaw, it is necessary to secure a tolerance that is greater than repeatability of the robot. It is the same logic when picking up and entering a workpiece. This part describes the focus, which stands for interface between machine and robot. In this training, focus is used for interface with the machine. Focus is able to be directly connected through FANUC CNC via Ethernet and is a DRL command provided by Doosan Robotics that can be used on Task Writer and Task Builder. The communication is available through a pre-mapped PMC address. The data type are bit, character, word, long, float, and double. And the corresponding signal can be read and write. Focus functions supported by each CNC may be different, so you need to check with the manufacturer. Please take a look at the table of focus length configuration. Address type, start address number, and bit offset settings are required to use DRL. The data that the robot reads from the machine can be used as a focus PMC read bit. The data written by a robot as machine can be used as focus PMC write bit. Let me explain DRL command to use focus communication. Focus connect is a command to connect the machine and robot through IP port and wait until the set timeout. Focus disconnect is a command to disconnect the machine from the robot. Handle's name can be set in focus connect. Focus get error string is a command to verify which error is string through error code in another command. Focus PMC read write can be used depending on the data type. You can read or write data by utilizing the parameters address type, start number, and bit offset on the handle set through connect. You can read or write data when focus connect is successful in flow and use the focus disconnect command when you have completed focus communication. Let's set the DLL commands described one by one. First, declare the variable in advance. Focus Connect can use three parameters: IP, port, timeout. So declare their three variables. Handle and error code are also declared in advance for use in other functions. For convenient use, match PMC address with keyword in advance. The keyword to be used can be set by the user. And you can enter the matched PMC address type, start number, and bit offset. Next is set focus function. Make a global declaration for the use of the robot interface write and handle. Enter the keyword that you matched in signal name and receive a value to set in VAL. Use this parameter as a parameter for focus PMC write bit. For example, to write robot online, call up and use pre-matched data type R, start number 3000, and bit offset 0 from focus PMC write bit. Errors that occur during write are recorded through TP log. Next is get focus function. It is the same way people set focus. For example, to write robot online, call up and use pre-matched data type R, start number 3500, and bit offset 0 from focus PMC read bit. Errors that occur during read are recorded through TP log. Next is wait focus function. Make a global declaration for the use of the robot interface read and handle. Enter the keyword that you matched in signal name and receive a return value in VAL. Use this parameter as a parameter for focus PMC read bit. If the read data and the value of the calling the function are the same, it will be break. If it is different, wait until it's the same. We will explain how to use the functions declared previously. IP, port, and timeout will be used as the values entered in the variable earlier. You can use set focus and wait focus. This part describes the DRS scripts for feeder settings. This slide for the pallet selection. Selecting a diamond-shaped sliding shelf. Make a slope with the inclined angle greater than 15 degrees. You need a device to fix the pallet so that it can always be located in the same position. Get pattern point. This command calculates the entire pallet coordinates based on the 4-point teaching and receive the return value. Row, column, stack, thickness, pattern, index settings are required. Stack stands for the number of layers, and thickness is in millimeter, the distance between point A on the first layer and point A on the second layer. The pattern provides 4, and the order of the pattern is shown in figure. The beginning and end points depends on the teaching. I will explain the variable settings that must be proceed to use the get pattern point. Enter the items and number of variables I explained earlier. Index declared a system variable so that the robot can continue its existing work even if the power is suddenly cut off. Next, array variable settings for offset. When using a sliding pallet, the location of the workpiece is different between the pick and place operation. If you are working on pick place with one pallet settings and the gap is evenly spaced, you can use offset it. I will explain about the pallet teaching. It is based on 4 points and more convenient to teaching while holding a workpiece. If the hole size is large, the center may be difficult to teach. Picking point is set based on when the shelf slides. The order of pattern proceeds from point to A to point B. The offset might be used by teaching in close contact with the bottom surface. Please refer to the figure on the screen. Global approach offset variable can automatically calculate to pick up the workpiece. We will execute trans using the tool coordinate system. It must be specified as a pose variable. It can be used in MoveL only when it is set to task type. Global target stores the return coordinates value based on index in get pattern point function. Global approach target stores coordinates value that reflect global approach offset based on the tool coordinate system in global target. This can be applied later in the MoveL command. This part describes the program in detail. This is digital I/O map configuration. Digital input requires a redundant contact points for using the safe device. The safe sensor should set protective stop auto resume and reduce the speed mode to divide into 2 areas. Safety I/O setting is required when using remote control mode. You can set the control signal task start, pause, stop, resume, sub on in remote control. In digital output, the output of gripper 1 and gripper 2 needs to be double action wired, and the rotary unit needs to be wired in double action as well. This is operation sequence for the first cycle. Gripper 1 only handles the workpiece before processing. The first cycle starts that gripper 1 pick up the workpiece from the pallet and place the workpiece into the machine to processing. This is operation sequence from the second cycle. Gripper 2 only handles the workpiece after processing. This flow could be changed, but it is necessary to determine the flow before the robot setup. After the first cycle, gripper 1 picks up the workpiece from the pallet. Then rotation to gripper 2 picks up the workpiece after processing from the machine. And then rotation to gripper 1, place the workpiece on the machine. And then rotation to gripper 2, place the workpiece in the pallet after processing from the machine. To help you understand, we will review flow chart. Declare system and global variables and declare focus function. Command focus link communication and then start main program. If it is the first cycle, start the initial settings such as tool weight and TCP. When you get a permission to enter the robot, pick up the workpiece from the pallet with gripper 1. Here, the index for picking up is 0. And then place the workpiece on the machine with gripper 1. The first cycle is done. When external reset signal is on, system index initialized to 0. If not, the robot transmits the cycle on signal to the machine. After that, the second cycle is executed and this cycle is repeated. I will explain how to configure the main program based on previous flowchart. G-loop count reverse variable is a repetition of main sub. When G-loop count reverse is 0, it can be used as before start, before the cycle repeat once. Tool weight and TCP are set before starting main program. In the first cycle, there is no workpiece inside the machine, so move the workpiece from the pallet to the machine using gripper 1. So call pick pallet by gripper 1 and place machine by gripper 1 declared as subprograms. The robot transmits the cycle on signal to the machine. After that, subprogram is called according to the flowchart described the previous slide. I will explain subprogram more detail from this slide. This is a flowchart and program that grips and ungrips for gripper 1. First, let me explain the grip part. Initialize signal from digital output 1 and 2. After digital output 1 signal is on, change the setting of gripper's tool weight. Subprogram is completed after waiting 1/2 seconds considering the gripper operation time. Next, ungrip part. Initialize signals from digital output 1 and 2. After digital output 2 signal is on, change the setting of gripper's tool weight. Subprogram is completed after waiting 1/2 seconds considering the gripper operation time. This is a flowchart and program that grips and ungrips for gripper 2. The control and flowchart of gripper 2 are the same as gripper 1. The difference is that gripper 2 uses digital output numbers 3 and 4. This is a subprogram that rotates the gripper's rotary unit. Swivel gripper 1 unit to rotate gripper 1 downward. Swivel gripper 2 unit to rotate gripper 2 downward. Initialize signal from digital output 5 and 6. Swivel gripper 1 changes digital output 5 and swivel gripper 2 changes digital output 6 to on. Subprogram is completed after waiting 1/2 seconds considering the rotary unit rotation time. This is a subprogram that pushes layer from the robot side. In general, after making a robot pose with move J, run swivel gripper 1 unit program. If the layer is pushed to the end, the robot TCP is located and the end of the ring attached to the shaft. When the robot retracts, it must move the robot TCP to the center of the ring to avoid interference between the ring and TCP. You can look at the red dot in the figure centered on TCP, and you can add a subprogram according to the number of layers. When the robot retracts, it must move the robot's TCP to the center of the ring to avoid interference between the ring and TCP. Also, you can add a subprogram according to the number of layers. This is a subprogram that increases the index according to the work completion status of the pallet. System index increases index 1 by 1 when each cycle is completed. If this increased index is equal to the row, column, stack multiplied value, the entire pallet operation is considered complete. When the pallet operation is complete, set system index to 0. If index becomes equal to the row column multiplied value, it is considered that one layer of that pallet operation is complete. When one layer of the pallet is completed, push the layer from the robot side. If it has multiple layers, you can add the additional condition. This is the same contents as the previous slide. This is a subprogram that picks up the workpiece before processing from the pallet. If it is the first start of the pallet, pull layer towards the robot side. If it is not, call Saber Gripper 1 unit and get pattern point is used to receive return coordinates according to the index. Based on that data, move to the target and call Gripper 1. Then after retracting, the program ends. We will take a look at the program in detail. Set MoveJ position variable to facilitate pallet operation and move it through MoveJ. It can call pull layer according to index number. Then call Saber Gripper 1 unit. The coordinates are returned to get pattern points according to the value of system index. On the basis of return target data, return approach target coordinates that have been moved by approach offset based on the tool coordinate system. Use global approach target variable and global target variable set at the top of the main sub for use interface activation. Move to the variable position through Move L and operate Gripper 1. This is a subprogram that places the workpiece before processing on the machine. Move J to the home position adjacent to the machine. Call Saber Gripper 1 unit for using Gripper 1. Write the signal that opens the door and wait until get the door open signal. Afterwards, check if the chuck is open and turn on the robot inside machine signal that the robot enters the machine. Enter the machine and move to the location of the jaw. Write the signal that closes the chuck and wait for the close signal of the chuck. Then call ungrip Gripper 1 and it retracts from the jaw. When retracting out of the machine is complete, write the robot inside machine signal is off. Write the signal on to close the door and then check the signal that the door is closed. Use global approach target variable and global target variable set at the top of the main sub for user interface activation. Move to the variable position through Move L and operate Gripper 1. This is a subprogram that places the workpiece before processing on the machine. Move J to the home position adjacent to the machine. Call Saber Gripper 1 unit for using Gripper 1. Write the signal that opens the door and wait until get the door open signal. Afterwards, check if the chuck is open and turn on the robot inside machine signal that the robot enters the machine. Enter the machine and move to the location of the jaw. Write the signal that closes the chuck and wait for the close signal of the chuck. Then call ungrip Gripper 1 and it retracts from the jaw. When retracting out of the machine is complete, write the robot inside machine signal is off. Write the signal on to close the door, and then check the signal that the door is closed. On this slide, you can see how the program was created according to the previous flowchart. This is a program that places the workpiece on the jaw and retracts from the machine. This is a subprogram that picks up the workpiece after processing from the machine. Move J to the home position adjacent to the machine. Call Receiver Gripper 2 unit for using Gripper 2. Write the signal that opens the door and wait until get the door open signal. Afterward, check if the chuck is closed and turn on the robot inside machine signal that the robot enters the machine. Enter the machine and move to the location of the jaw. Then call Gripper 2 and write the signal that opens the chuck and wait for the open signal of the chuck. And then retract from the jaw. When retracting out of the machine is complete, write the robot inside machine signal is off. Write the signal on to close the door, and then check the signal that the door is closed. On this slide, you can see how the program was created according to the previous flowchart. This is a program that picks the workpiece from the jaw and retracts from the machine. This is a subprogram that places the workpiece after processing on the pallet. Move J to the home position adjacent to the pallet. Call Receiver Gripper 2 unit for using Gripper 2. Save data with -1 in the system index to a local variable called index. The formula for placing the finished workpiece in an empty position on the pallet. Return the target data, calculate approach target, and move to the location. After the operation of ungripping Gripper 2, it retracts and the program ends. Set Move J position variable to facilitate pallet operation and move it through Move J. Then call Receiver Gripper 2 unit. The coordinates are returned to get pattern points according to the value of system index. The difference from the subprogram pick pallet by Gripper 1 that global offset is add on global target. The location of the workpiece is different between the pick and place operation. The data is returned by reflecting the declared global offset value. On the basis of return target data, return approach target coordinates that have been moved by approach offset based on the tool coordinate system. Use global approach target variable and global target variable set at the top of the main sub for user interface activation. Move to the variable position through Move L and operate ungrip, gripper 2, and retract. A final part, we will summarize machine tending application. We can link one robot to multiply machines. It can be used efficiently using additional axes. The height of the additional axes needs to be installed so as not to be affected by singularity the robot work area. The slide example photos are from Benson's range extender. We can provide each pattern setting using get pattern points and make it easy programming work for the various workpiece. And Focus enables simple communication than using PLC, and it can help to maximize production and workers to more important tasks. And our system has a compact that enables to use space efficiently. We will check the points to consider to use machine tending. I made this slide the form of the question and answer. Question 1 is it possible to change chuck? Yes, when handling heavy objects, tolerance must be secured in consideration of the robot's payload and stiffness. Question 2. What are the conditions for using compliance control? Our tool weight must be set according to the type of gripper, the presence or absence of the workpiece, and the states of before or after processing. Is the rotary unit essential when using the dual gripper? Rotary unit is an option. If you don't want to use RTU, please refer to page 8 and 9 of these instructional materials. We recommend it to reduce the cycle time. What is needed to prevent the finger from slipping? It is necessary to check the gripper's gripping force and review the material and shape of the finger, especially when working with two fingers. The shape of the finger should be designed so that the gripper does not drop the workpiece. Three fingers are suitable when working with circular workpiece. Any tips on how to fix the base of the robot? Robot base should align the end of TCP with the y-axis position of the work unit to facilitate work inside the machine. For manual operation of the door, the distance between the door of the machine and the origin of the robot base is located about 750 mm for H2515 model. The distance between the chuck and the origin of the robot base is located about 950 mm for the H2515 model. Lastly, I will show you one video of collaboration between our H2515 model and Cobot storm machine of Doosan machine tool. It shows not only the workpiece, also chalk plates can be replaced by robot. If you have any question, please feel free to ask. We will reply for your question through chat or microphone. If you don't have any further question, we will finish the training. Thank you for participating in this training. Thank you.